Driverless vehicles are going to change transportation more dramatically than the invention of the automobile itself.
I think the biggest challenge is going to be to free our brains and free the brains of our engineers.
You have to do something different than you've done, different than they've seen in the past, and you have to be visionary. You have to think a little more like an artist.
At Arconic, we are exploring not only new material compositions, but new methods of making the materials.
With advanced manufacturing, you can literally make anything. In a fragment of the time, in a fragment of the cost, you can have multiple prototypes, test them out, fully functioning.
We're moving into an era of first driverless cars and then fully autonomous cars.
Everyone in the car is going to be a passenger. People are going to use virtual reality and augmented reality within cars, so it kind of doesn't really matter where they are.
It will be connected to the Internet of Everything, that global brain that is so essential in tomorrow's smart society.
You could keep them moving so that there would be very few that would be parked.
It will not only solve the congestion problem, it will also solve the infrastructure problem.
It changes the economic equation, and it really doesn't make sense for individual ownership anymore.
We're moving away from the benefits of ownership to the benefits of access.
With additive manufacturing, we can create designs and structures that could never be created before.
Technology around the micromill. This allows us to achieve better formability, shapes and details on the body structure that weren't achievable with traditional materials in the past. And it also allows us to drive the strength up. When you have a higher strength material, you can use less of it, so you can continue to drive the weight of the car down, which will be very important to fuel efficiency.
We are right now at the very early stages of a revolution in materials.
Computational understanding of the materials will be linked digitally to the design. It will allow you to better understand at the very early stages what you can achieve from a design standpoint for both the shape and the function.
As the surface gets more and more congested, it's going to become more interesting to be able to move through some of that congestion by moving up into the air.
I mean, who wouldn't want to have a flying car?
We won't even have traffic flight controllers. It'll all be done algorithmically.
We're going to do things that we never imagined in the next century.
We could actually create a world that is an even better place to live on than the one that we are on today.
I think the planes are going to really change quite dramatically, actually, because we're seeing greater efficiencies in planes that are more like flying wings.
I think future aircraft will be more aerodynamic. At Arconic, we have been working on features on the surface at a very small size. We call them riblets, that are based on the scales of a shark. It's taking a look at what is in nature that provides for more hydrodynamic or aerodynamic, not only overall shape, but on the surface itself.
Thinking about a fixed-wing passenger plane carrying, let's say, 200, 400, up to maybe 1,000 passengers, the experience is really critical.
Everyone wants more space, and everyone wants more comfort. At the same time, everyone wants planes to be cheaper. But probably it's going to interact with things like virtual reality and augmented reality.
More specific destinations, more points that people can leave from and get to is absolutely something that will continue into the future.
Propulsion systems will be required to continue to be more efficient with higher thrusts, which typically means that you're going to be operating at higher temperatures, burning your fuel more efficiently. It will result in the need for much higher temperature resistant materials.
We could imagine a propulsion that's supersonic. That's supersonic and gets us from here to Europe in an hour or so. That's going to change the world.
I think Arconic's going to be right at the forefront of making that happen. That's in our DNA and it's what we do.
I think when you look at cities in the future, you will see less of the square, boxy shape of current skyscrapers and buildings.
They won't feel like something that was humanly created. They will feel organic.
It's going to be much faster to construct buildings because of drones and because of robotics. The faster it is, the more risks we can take.
Once we're actually able to 3D print a wall, we no longer have the need for flat walls. Every wall can become an artistic centerpiece. We're going to have lots of freeform structures that are unlike anything that we have today.
People are happier and they are more productive the more they're exposed to green spaces, to trees and to plants. And so the more we can incorporate them within buildings themselves, the better it's going to be for everyone. But that poses new kinds of challenges for constructing buildings. You need to get natural light in, you need to have air circulating, you need to have buildings that are strong enough to accommodate these kinds of plants.
Looking differently at what types of materials, how you join those materials, how you surface treat those materials to enable the green space to thrive, while at the same time not having an adverse effect on your structure.
We'll see buildings that are self-sufficient, so it produces its own food.
To make taller buildings in the future, we have more advanced alloys like aluminum lithium, which is even lighter than standard aluminum. These types of things will flow from automotive into building and construction for lighter, stiffer materials.
There's no limit to how tall we're going to make the showcase buildings.
Active surfaces, surfaces that can clean itself.
We have introduced a technology that's called EcoClean. It pulls pollutants out of the air, and as the rainwater washes the building, it washes away the pollutants.
The whole drive for net zero energy consuming buildings, for a building potentially actually producing energy, that is not far-fetched.
The structure will be not just passive, but responsive and reactive to what's happening to the structure throughout its life. Engineered surfaces can be designed that they provide functionality to the building.
They will be able to be self-repairing, and they will also be much more shaped around human needs.
And the addition of all these, what I would almost call biologically inspired systems to make it adaptive.
We create the future, and we all have the capacity to be positive change makers. So why not start today?
Humans will become multiplanetary.
Over the next 20 to 40 years, certainly we will travel to Mars.
In some respect, it's going to be easier to get humans to Mars and to have them live there than we think.
We've just saw that a mission was accomplished, to explore a comet. Every day we learn more about what's going on in outer space.
One of the things that we have to remember that to get to outer space, you have to defy gravity. So lightweighting will be critical for future spacecraft and rockets. This is another way that Arconic can play a role with advanced materials.
We would have to be able to utilize the elements and the materials that are located on other planets.
Asteroid mining is looking for platinum-based minerals. Just one football-sized field of platinum-based minerals that we could grab and drag down to Earth could be worth the equivalent of $1 trillion.
The way that most people think that a space elevator would be built is that we go and capture an asteroid, we put it into orbit, and then we go and put robots on it, and we mine the asteroid, and we extrude a cable or cables from both sides of the asteroid to send that cable through the atmosphere onto a point on the equator of the Earth.
There are many exciting technologies that will come to space vehicles. Some of the technologies associated with control that allow someone to reuse the vehicle. Arconic can bring technologies like additive manufacturing and new materials that will enable all of that capability.
With aluminums, with nickel alloys, with titanium alloys, and advanced manufacturing methods to make them lighter so that once they get to outer space, there can be more food, more supplies, more equipment.
If we can dream it, we can achieve it.
I think what most people don't know about us is that we're an ingot to install company. So we can produce the ingot, specifically titanium ingot, and we already manufacture components ready to be installed on an airplane. And that's really something that we're uniquely positioned in the value chain to do.
We are the one source that an OEM or an end customer can come to for that entire solution. We can help you set the standards and the specifications up front, and we can give you a qualified, certified part that is directly ready to go onto your airframe or onto your engine at the end of the process.
With 3D printing, we can make intricate, complex shapes that we couldn't make any other way.
These are real parts. They have real requirements from real customers, and they're parts that potentially could be on the airplane that they're riding on tomorrow.
3D printing is going to work its way into every step of manufacturing. The key is, by bringing materials knowledge and manufacturing process knowledge, and by being able to work with any type of additive manufacturing, what we're going to do is we are going to be at the forefront of introducing additive techniques at each of those steps to create the most value both for our customers and for ourselves. And we're going to be able to do things that have never been done before that keep us at the forefront of working with our customers, the airframe customers, the engine customers, to deliver products that push the envelope